Hi everyone. By the end of this video, you should be able to sketch a graph of a parabola given any form. But in order to do this, we're going to want to work between all the forms so we can find things like the vertex, the X intercepts, so on and so forth. So right now we're given the equation in standard form and we want to find all this stuff. But we're going to start with the vertex. So remember, the vertex is found by transforming the parent function y equals x squared. So don't write this down. But if I had like y equals x minus 1 squared plus 2, the parabola would have been shifted right 1 up 2. So to start at 0, 0, gone right 1 up 2. So then the vertex would be 1, 2. Okay, so to find the vertex, we want the function to look like this. We want it to be in vertex form. Okay, and in order to do that, we need some binomial squared here. And in order to create a binomial squared, we learned a method where binomial squared is a perfect square trinomial, and we figured out a way that we can force this to become a perfect square trinomial so we can get something squared. And the way we do that is by completing the square. So I'm going to kind of roll through those steps here so we can remember how to do that. And it's actually going to help us put a quadratic from standard form into vertex form. Okay, so say we have the quadratic that's 0 equals 3x squared minus 6x, not plus 6x, minus 6x minus 5. The first thing you want to do when you complete the square is move that 5 over. So we'll get 5 equals 3x squared minus 6x. Now you want to get rid of this coefficient because that won't let us make this a perfect square trinomial because 3 is not a perfect square. Okay, so you can't just divide it out, but what I'm going to do is factor it out, because if you factor it out, it's really reverse multiplication, just like division is, but it won't go away because that value is actually going to be important later. So if I factor out a 3 times x squared gives me 3x squared. And then 3 times, this would be negative 2x, will give me negative 6x. So I'm just factoring out that 3. Then I'll do something to fill in my blank here, close that up. Okay, so what would I need to fill in the blank? Well, I'm going to take half of my b term. So divide that by 2, I get negative 1. And then I'll square negative 1, which is going to give me 1. Now the reason I factored this out is because I want you guys to think about what are you really adding to the right side here. So I know you put in a 1, but if you distribute this out, it would be 3x squared minus 6x plus 3. So what you're really adding to this side is 3. And whatever you do to one side, you have to do the exact same thing to the other. So this would mean to be 3 plus 5. Think about that. Okay, so what you would get is 8 equals 3 times, now factor this. It's got to be x minus 1 times x minus 1, which is x minus 1 squared. You can get that hint from this number here. And you can now put this in vertex form by moving the 8 over. So my function would be f of x equals 3 times x minus 1 squared minus 8. And it's really important to kind of factor it out here because that 3 doesn't just go away. That is actually going to tell you how fat or skinny your parabola is because this is a vertical stretch. You multiply all the y values by 3. Anywho, this was just an example. That wasn't the actual problem I was giving you, so I'm going to erase that. The actual problem I was giving you is now written as f of x equals 3 times x minus 1 squared minus 8. So that means the parabola has been transformed. X is negative 1 here. The y has been transformed negative 8, which means the vertex is 1, negative 8. Whatever is done to the x, remember, does the opposite of what you think. So that's going to be my first step into plotting this. I'm going to plot my vertex at 1, 5, 6, 7, 8. Negative 8 would be right here. Next thing you may want to plot are some other points. And we want to pick points that are really important in this graph. So I'm going to pick the y-intercept and the zeros, which zeros are another word for x-intercept, which is another word for roots, which is another word for factors. You may hear it in different ways. They're all synonyms. Okay, so we're going to find both the y-intercept and the zeros. Now, to find a 0 or an x-intercept, your y would have to be 0. To find a y-intercept, your x would have to be 0. Y-intercept is probably a little bit easier, so I'm going to start with that. So my function again, and you can use either form, but it was 3x squared minus 6x minus 5. And all I would have to do is plug in x equals 0. So 0 squared is 0 times 3 would be 0. Minus 6 times 0 is 0. Minus 5. So your y-intercept would be at 5. And if you wrote that as a point, it would be 0, 5. So again, the point of this is to sketch a graph. So I'm just going to, and that should be a negative 5, by the way. Sorry, I can't do my basic computation, but that makes a lot more sense here. It would be at -5 on the y-axis. Okay, now I'm going to want to find x-intercepts, which means I'm going to need to set y equal to 0. So let's actually do that. I would have 0 equals 3x squared minus 6x minus 5. And how would I solve something like that? Well, think it's set equal to 0. It's a quadratic. I should think zero product property. I should try and factor. So if I try and factor, I will need something that multiplies to 3x squared. So that's 3x and x. And something that's also going to multiply to 5 would be here. So that could be like 5 and 1. But if I do 3x times 5, I have 15. And 1 times x is 1. So I have 16 x's. That won't add to -6. Or if I switch these around and I put a 5 here and a 1 here, well, 3 times 1 gives me 3. 5 times x gives me 5x. There's no way that's going to combine to be 6. So actually, this problem won't be factorable, just saving you a little bit of time, although that's the first thing I would want to check for. Now, if something's not factorable, you can use the quadratic formula to solve any quadratic for x, whether it's factorable or not. So that's what you're going to need to do here. So remember, x equals opposite of b, plus or minus the square root of b squared minus 4ac, all over 2a. I want you to go ahead and plug in a, b, and c, a, b, and c, and go ahead and calculate that and try to write it in the simplest form. I'll come back with the answer. Okay, if you've done quadratic formula correctly, this is long, but I showed all my steps. So you plug them in, and you probably maybe ended here. Okay, but I went a step further and actually simplified the square root of 96. 96 is 16 times 6. The square root of 16 is 4, and 6 is left over. And then I went a step further and went backwards from finding a common denominator, and I split it up. So really this is 6 divided by 6, and 6 divided by 6, which you can then simplify. 6 divided by 6 is 1, 4 and 6 can be simplified to 2 over 3, root 6. Okay, so that's why I couldn't factor, is because these aren't whole number solutions. I don't think I would ever guess that in trying to guess and check factor. Now, in order to plot these, it'd probably be most useful to get these in decimal form. Although, if I ask for your zeros, I want exact, which this is exact. Okay, but to plot them, I plugged them into Desmos to find my, my decimal form, which is this and this. So one is 2.63. Okay, so I will plot 2.63. It's like 2 and then a little bit more. And the other one is -0.63. So it's a little bit less than -1. And if done correctly, parabolas are symmetrical over their, let me draw a picture, over their vertex here. So they should be equally far away from the vertex if you look at this distance and this distance. So that's a good way to check that you've got the correct x-intercepts. And now that I have all that, I can actually draw a graph through the points and get a pretty good sketch. Now, this parabola is really, really skinny, which makes sense because our a value is 3, which would take all the y values and multiply by 3, which would make them taller, which would make the parabola stretch. So those are good ways to be self-checking that you've graphed it correctly. Okay, the other things you can find, we've already talked about, are max and min values, so I'll leave that for you, domain and range, transformations, so that's just kind of what we talked about before. But the last thing we need to talk about is the axis of symmetry. So really the axis of symmetry is the line of symmetry, which you can draw, but I want the equation for. So if you drew it, this is the line of symmetry, which goes to the vertex, which is what I just talked about. But I want to write that as a line, and it's a vertical line, which means the y values are changing, but the x value always remains the same. And for this case, the axis of symmetry, my x value is always 1. Like this is 1, 0. This is 1, -1. This is 1, 1. This is 1, 5. This is 1, -5. So I'm trying to say is x is always 1. The y values are changing. So the way you write the equation for a vertical line is x equals, and it's x equals 1. So I don't just mean draw, I mean find the equation. Okay, so that is how you would sketch a parabola. You're going to need to use knowledge of factoring, quadratic formula, completing the square. It all kind of comes together to get this end goal here and to be able to model a function on a graph. I'm going to leave these 3 things here for you to try on your own. I will come back with the answer, but again, this is a good review of old stuff, so try it first. Okay, here are my answers to those for you to self-assess. Okay, remember I'm asking for the maximum or minimum value. The x value tells us location, the y value tells us the output, which would give you the value. So the value is -8. If I asked for the max or min point, you would tell me -1 or +1, -8. Domain, keep in mind that this graph has arrows pointing at the end, so it's not going perfectly vertical. It's going to keep like going in this general direction of expanding wider, which means that if it did that forever, it would hit all x values in both directions. And that's why the domain is -infinity to infinity. Range, we're talking about y values. So the lowest y values is -8. And then the arrows point up forever, so the highest one will be infinity. And then transformations, you translate right 1, down 8, and it's vertical stretch by 3, which is just kind of reflecting on what we said up here. So as you can tell, everything we learned in the first chapter is going to help us study specific functions and specific graphs. So if it didn't make sense before, I hope it makes sense a little bit more each time, but it's really important that you understand those things, so please come and ask questions. Have a great rest of your night.